In a world of data, who do you trust? A central bank or a distributed network? Now, this isn't just some philosophical question. It's at the very heart of how we manage information today. And for all you engineering students cramming for exams, getting this right is absolutely crucial. So in this explainer, we're going to break down these two fundamental systems, blockchain and traditional databases.
All right, to really nail this down, here's our game plan. First, we'll look at the two big-picture data architectures. Then, we're going to zoom right in on the anatomy of a blockchain itself. After that, we'll put them head-to-head in a detailed 7-point comparison. And finally, we'll wrap it all up with the key takeaways you'll definitely want to have in your back pocket for your exam. So, let's start at the top with the big picture, the two fundamental data architectures.
Okay, what you're seeing here are the two basic ways you can structure a network. On the left, that's the centralized model we all know, kind of like a classic client-server setup. All roads lead to one central point of control. But on the right, you've got a decentralized network. Here, everybody's connected to everybody else, and there's no single boss in charge.
So here's the bottom line. A traditional database, like the kind your bank uses, organizes data neatly into tables and is completely controlled by a single administrator. A blockchain, on the other hand, like the one that powers Bitcoin, is a distributed ledger. It's shared across a whole peer-to-peer network where no single person is calling the shots. But how is one of these chains actually, built? That's what we're going to dig into next.
It's actually a really elegant process when you think about it. It all kicks off with what's called the genesis block. That's the very first one in the chain. Then, as new transactions happen, they get bundled together into a new block. That new block gets its own unique, basically tamper-proof digital fingerprint, which we call a hash. And here's the real magic. It also contains the hash of the block right before it, literally chaining them together forever.
And this visual just makes it all click, right? You get this sequential chain of blocks, and each one is cryptographically locked to the one before it. This is where all that famous security comes from. See, if you tried to go back and change an old block, its data would change, which would create a totally different hash. That new hash wouldn't match the one stored in the next block, and poof, the chain would instantly break, making the tampering obvious to the entire network. Okay, now that we have those foundations down, let's get to the main event. This is the core of what you'll need for your exam, our 7-point comparison.
First up, the whole idea of centralization. This really just boils down to a super simple question. Who's in charge here? Is there one single boss, or is it more of a group effort? And the answers could not be more different. A traditional database is totally centralized. The database administrator is king. But in a blockchain, there is no king. Control is spread out across the entire network, and every single participant has their own copy of the ledger.
Next up, fault tolerance. Or in simple terms, what happens if something breaks? Can the system take a hit and keep on running?
Now, this is a huge win for blockchain, because that ledger is copied across thousands of different computers. A few of them, or heck, even a lot of them, can fail, and the network just keeps on chugging. A traditional database, though, often has what we call a single point of failure. If that main server goes down, the whole system can just go dark. Okay, let's talk about something really practical, storage space. How much data can these systems realistically even hold? And here, the tables are completely turned. Traditional databases have a massive advantage. They run on these super powerful dedicated servers that are built for gigantic amounts of data. Blockchains, on the other hand, are limited by the storage space on the regular computers of all the people participating. All right, pay close attention to this next one, immutability. This is a critical concept and really one of blockchain's signature moves. The question is, can you change the past? Blockchain ledgers are immutable. Once a transaction is written down, it's basically set in stone. You can't change it. This is exactly what prevents fraud, like someone trying to spend the same digital coin twice. Now, in a traditional database, someone with the right permissions, like an administrator, can totally go in and change, update, or even delete records.
So what about transparency? Who actually gets to see the data?
And again, we're looking at a fundamental difference in design philosophy. Blockchains are built to be transparent. Everyone on the network can usually see the entire history of every transaction. Traditional databases, they're the total opposite. They're designed to restrict access and control exactly who can see what.
Okay, what about speed? How fast can you actually get things done?
This one reveals a really key trade-off. Traditional databases are lightning fast. Why? Because they operate on trust. Blockchains, by their very nature, assume nobody is trustworthy.
They rely on these complex consensus algorithms to get the whole network to agree that a transaction is valid. And all that verification, well, it just takes time.
And finally, let's talk about access. Who is even allowed to play in the sandbox in the first place?
And this really brings everything full circle. Access to a public blockchain is usually open to anyone who wants to join the network. Access to a traditional database is the exact opposite. It's locked down tight and limited to a very small, very trusted group of people. Okay, that was a pretty deep dive, I know. So let's boil it all down into the absolute must-know takeaways that you're going to need for your exam.
So look, if you only remember one thing for your exam, let it be this. It is all about the trade-offs. If you need crazy high speed and tons of storage, and you're in a controlled, trusted environment, like, say, a company's internal data, a traditional database is the no-brainer. But if your goal is to create trust and transparency between a bunch of people who don't know or trust each other, then blockchain is absolutely the right tool for the job.
And that really leaves us with a final thought to chew on. The choice between these two systems, it's not just a technical one. It's a fundamental decision about what we value more in our digital world: efficiency and control, or security and transparency. Something to think about.